Hi, this video will cover section 7.5, Systems of Inequalities. We will be sketching the graphs of inequalities in two variables. We will be using X and Y. So we're going back to the XY plane or the 2D systems. So we're going to be solving systems of inequalities. So we could graph one inequality by itself in two variables. So it will be graphed in the XY plane. But we could also solve a system of inequalities by looking at the intersection. And this intersection will be a little different than systems of equations because instead of being lines intersecting or overlapping, there will be areas or colors that are intersecting. So we will also be using systems of inequalities in two variables to model and solve real life problems. So let's get started. And we have here two statements. The one on the first one, 3x minus 2y less than 6. And we have another one, 2x squared plus 3y squared is greater than or equal to 6. So both of those statements are inequalities in two variables. An ordered pair A comma B is a solution of an inequality in X and Y when the inequality is true after A and B are substituted for X and Y. So if we were to substitute, imagine A and B are numbers. So A, we get that substituted for X, and then we will get B, another number. We're just trying to generalize it. Substitute that for Y. And so if we were to do that and we get a true statement for both inequalities, or I guess for one inequality right now, then that will be a solution of an inequality. If we're talking about a system of inequalities, then it will have to be true for both or for whatever inequalities we have. So the graph of an inequality is going to be the collection of all of those solutions. So all of those points for any numbers A and B that satisfy the inequality, that will be the collection of solutions. And when we put them all together, and you will see in a minute, they are going to form an area, and we will be shading that area or coloring it. So to sketch the graph of an inequality, begin by sketching the graph of the corresponding equation. So at first, we're going to treat it like if it was a regular equation. So then the graph of the equation will usually separate the plane, the Cartesian plane, the XY plane, into two or more regions. So it's kind of like you have your XY axis, and then we graph an equation, and then you have your plane separated into an area above the line and below the line. So that is like a separation of into two regions, but this could be separated into more regions depending on the type of inequality. Also, in such region, one of the following must be true. All points in that region are solutions of the inequality, or no points in the region is a solution of the inequality. So after we separate it, I guess I could say I want all my solutions to be here. The set of points that I was talking about. And the other area here, this will contain the area that has no solutions. So again, this will be considered the area of no point is a solution, and then the other area here is where we have all the solutions, which are all the little points that I was telling you here. And those points are the ones that will satisfy the inequality. So to graph the graph of the inequality, we can determine whether the points in an entire region satisfy the inequality by testing only one point, and that will be enough. So if I select, if after dividing the region, the Cartesian plane or the XY plane into two regions, if I select just one point from here and I substitute it back into the original inequality and it gives me a true statement, then that will be the region that contains all the solutions. So before we determine the area that contains all the solutions, we will replace the inequality sign with the equal sign, just like we were saying that we will treat it as an equation first, and then we sketch the graph of that equation. And then after that, based on the signs, we will determine if we will be what type of line we'll be using. So I'm going to start with solid lines, and those will apply for the symbols less than or equal to, and also greater than or equal to. And that is because we have that equal part here. And so that's why we need a solid, so a regular line, like if you were graphing an equation. So whether it's less than or greater than, we will be using a solid line, because the solution could also be on the line. That's why you have that equal part of the inequality symbol. Now we will use a dash or dotted for the symbols less than or greater than without the equal part. So it's important to remember that, because in that case, the points that are exactly on the line are not solutions to the inequality or to the system of inequalities. Then second, we will test one point like we discussed over here. Test one point in the region, and it sits here in each of the regions. I just pretty much test one region, but if you want to make sure, you can test both, because if you test one region, if you get a false statement, I promise you that if you did it correctly and you test the other region, you will get the others. Okay, if first you get a true statement, the other one will be false, the other region, or vice versa. If you test a point and you test it and you get a false statement, then for the other region, you will get a true statement. Now, if you get true for both regions, then you're doing something wrong. And same if you get false statements for both regions. And actually, I'm going to share a tip with you. The easiest point to test is the point 0, 0, because, I mean, you don't have to do much. But we will see some examples. If the point satisfies the inequality, then you shade that entire region, and that will signify that every point in there satisfies the inequality. So this is just like the easiest to test. Now, if this point is in the on the line, then I don't recommend you test it, because we don't know if it's gonna be I could give you a false statement, and then I mean, you could still figure it out, but it's better to pick a point that is not on the line. Okay, so this is the easiest point to test. Now, if you're not very good with like keeping track of negative and positive signs, then I recommend that you pick a point in the positive X and positive Y region, perhaps in quadrant 1. Okay, so we're going to test, we're going to graph the inequality, and we already have the graph here, so just pretend that you don't see it. And let's see. So first step, First thing we're going to do is we are going to graph the equation y equals x squared minus 1. So to graph that, a quadratic parabola, a quadratic function, right? We know that the vertex, we think about transformations, we know that the one here is telling me that it shifted the parabola 1 unit down. So instead of being at 0, 0, like the parent function, it will be at 0, comma, negative 1. Now, if I want to find the x-intercepts, we could let y equal to 0 and then solve for x. So if we take the original equation, and in this case we have a difference of squares, so we can factor this out into x plus 1, x minus 1, and then we said let y equal to 0, and then by the zero factor property we could equal each factor to 0 and then solve for x one at a time. So x is equal to negative 1, and then for the other factor it will be x is equal to positive 1. And to find the y-intercept, we could let, so we have two x-intercepts, negative 1 comma 0, and also 1 comma 0. And then for the y-intercept, we can only have 1 in this case because we know the quadratic is a real function. So we let x equal 0. This is great review for your exam. So we take the original equation, we let x equal 0, and then we solve for y. So this will be, I'm going to write the equation so you see what I'm doing. So this will be y equals 0 squared minus 1. So this will be y is equal to negative 1. Actually, I feel like I did something wrong here. No, yes, it's okay, it's okay. So we got that our y-intercept is going to be at 0, comma, negative 1. So now I'm going to graph my own. So let's go ahead and plot the x-intercept. So this is 1, this is negative 1. So we have our x-intercepts there. And then we had our y-intercept that we found at 0, comma, negative 1, so right here. And then we have to determine, based on the inequality symbol, we need to determine if we're going to use a solid or a dashed line. Since we have the equal part, we're going to use a solid line. So I can start by connecting those, the y-intercept and the x-intercepts. And I'm just going to make a rough sketch like the one we have below here. Well, I guess we could find 2 more points. Like if x is equal to 2 and we substitute it into here, we will have 2 squared, that's 4, minus 1, 3. Okay, so that will give us a better line. Okay, so, and this was supposed to be a curve. Okay, so now we're going to test the region. And remember, I told you the easiest point to test is that 0, 0, because, you know, you don't have to do much. So if we do that, and I'm going to do that over here. So we're going to test 0, 0. So we take the original inequality, y greater than or equal to 0 squared minus 1. And we're going to, well, actually, I kind of rushed here. That should be x squared minus 1. Now we're going to substitute x with the 0, and also the y with a 0. That's how we test the point. So 0 greater or equal to 0 squared minus 1, or 0 is 0 greater than or equal to than negative 1. So that's the question. What is bigger, 0 or negative 1? The answer is 0, because it's just bigger. It's on the right side of negative 1. So this is a true statement. So what that means is that the region that we will be coloring will be the one that contains that point that we tested. 0, 0, because it gave us a true statement. So here's our point, 0, 0. And remember, we got a true statement. And so that whole area that I shaded or colored or highlighted, that is the solution. Will the line also be a solution? Yes, because of that equal part on the inequality symbol. So it does have the greater than or equal to. Another thing that you could use, it's probably a little confusing for all graphs to use, but if you see if your inequality is already solved for y, meaning that is y greater than or equal, or y less than or equal, or without the equal, if you have it in those terms, you can think of greater than or greater than equal than as above. You're shading above the line, because it's whatever points will be greater than or equal. And so if it was less than or less than and equal, it will be below the line. But the safest thing to do is to pick a point, test it like we did here, and see if you get a true statement. All right. So example 1 is a nonlinear inequality in 2 variables. Remember, we had x squared, we had y. Most of the following examples involve linear inequalities, but as you could see, we could also have quadratic inequalities. So in this case, we will have the type just like linear functions, where you have an x, you have a y, and a and b are just the coefficients. So a is the coefficient of x and b is the coefficient of y. They're just real numbers. And then c is the constant term. And here we have that a and b are not both 0. So that means that we could have a equals 0 or b equals 0, but not both at the same time. That's what the statement says, but not both. Okay, so if a was 0, then we will just have this part ax. I'm sorry, if let's say if b equals 0, then we will have an inequality like this: ax less than c, or greater than, or all the other inequality symbols. And on the other case will be if a equals 0, then we will have just this part right here, by less than c, or by greater than c, or all the other symbols. Same with this one, we could have ax greater than or equal to c, or ax greater than c, and then I'm missing one, ax will be, which one am I missing? Less than or equal to c. Okay, and here I'm missing b. Remember, b is a number, a is a number, c is a number. So it's okay to have one of them being 0, but not both at the same time. Not both. Okay, the graph of a linear inequality is a half plane. So those are the ones that divide the plane nicely into two regions. And then those two regions will be on either side of the linear inequality. And so if we have something like in terms of y greater than something greater than or equal, or y less than, sorry, not less than, but greater than, and then something, we will be shading above the line. And the other case will be if y is less than or equal to something, or y is less than or without the equal, less than something, then we will be shading below the line. But remember, the safest thing to do, especially if you are taking an exam, is to test your points. And then remember that solid lines happen here and here. Those are solid lines. And then here and here we will have dash lines, like broken lines or dotted lines. Okay, so now we're going to move to systems of inequalities. And systems of inequalities have many practical problems, many, I guess, practical applications in business, science, and engineering involving systems of linear inequalities. A solution of a system of inequalities in X and Y is a point, X comma Y, an ordered pair that satisfies each inequality in the system. So in this case, it has to satisfy either both or all three or all four or as many inequalities as you can have. So to sketch the graph of a system of inequalities in two variables, first sketch the graph of each individual inequality on the same coordinate system. And then you will find the region that is common to every graph in the system. So this is when I have my classes in person, I love to bring coloring pencils or color pencils and just have my students color them. It's very relaxing. So right now, since you will be taking your exam on WebAssign, I will be showing you how to do this by hand, but also on Desmos. So the region that they have in common, if you think about overlapping colors, if you have ever like done any coloring in your life, for example, if you mix, let's say blue, and you mix it with yellow, you make green, right? So whenever those two colors will be overlapping, that is what we will be considering the area that they have in common, and therefore that will be the solution to the system. And we call that the solution set to the system. So it will be whatever they do have in common for the system of linear inequalities. And it is helpful to find the vertices of the solution region. So those vertices are actually going to be the intersection points of the lines. So I'm going to go back one slide, and we're going to revisit this concept here. So we have something written in terms of just AX and then a constant. I don't know if you remember, but those are going to be vertical lines, just like we did with X equals to a number. And if we have B y, and then a constant, those will be in the shape of a horizontal line. So that is also helpful because the above and below statements that I gave you down here, they're not going to apply to a vertical line. So if it's less than, it will be to the left side. If it's greater than or equal, it will be to the right side, what we shade. And then if it is greater than, to the on the right side of the line, and if it's less than, AX less than C, it will be on the left side of the line. And remember, we're talking about for vertical lines. We will be thinking in terms of left side, right side, instead of above and below. So if it's greater than, it's going to be on the right side. If it's less than, it's going to be on the left side of the vertical line. So here we do have three inequalities. And for the first one, we could graph it by, I'm actually going to number them, 1, 2, and 3. And so for the first one, we start by converting it to an equation. And however, let's do something. I think this might be useful if we say what kind of line we will have. So for the first one, it will be dash line. The second one also a dash line. And for the third one, we will have a solid line. So I'm going to be solving for y on this inequality. So if I say negative y is less than, I'm going to take this positive x across the inequality symbol. It will be negative x, and then I have a plus 2. Now I want to have y less than, not negative y. So what I do here, and please pay attention to this part, you multiply by negative 1. Now the fact that we're multiplying by a negative quantity is going to cause the inequality symbol to be reversed. That is just the rule. It's like you are mirroring the inequality. So negative 1 times negative y will be positive y. And then negative 1 times negative x is going to be positive x. And then negative 1 times positive 2 will be negative 2. So that is the inequality that we will be graphing. So as you notice, we are going to be shading above. So in this case, if we use the y equals mx plus b, the slope-intercept form, we can notice that the negative 2 is representing the y-intercept. So the y-intercept is going to be the point 0, negative 2. And the slope here is the coefficient of the x, which is a 1. So that means that our rise over run will be 1 over 1, or 1 up, 1 to the right from the y-intercept. And it's also important to mention again that the line will be dashed. So you could see, I'm going to graph it here. So we're going to have, I'm going to trace this again. Okay, so negative 2, that's my y-intercept. I'm going to draw an open circle because that is not a point on the graph. And then I'm going to use the slope. So I'm going to go 1 up, 1 to the right. So right there, 1 up, 1 to the right, right there, and so on. So this is going to be a dashed line, not solid, remember, because we don't have the inequality symbol. Now, I already know that I am going to be shading above. But just to make sure, we're going to test. And what is the easiest point to test? 0, 0. So and then I can just substitute it here. If I substitute, I'm going to write it down here. So x minus y less than 2. So if I substitute the 0.00 to make sure that's part of the solution, it will be 0 minus 0. Is 0 minus 0 equal to negative 2? Of course it is. So it's a true statement. So yes, we were shading the right area. Okay. Now the next line is going to be dashed, but it's also going to be vertical. So it's a dash vertical line or vertical dash line. So that one's going to be pretty easy. And it's going to just go across negative 2. So that's negative 1, negative 2. And again, we have to draw it not solid, dash, or dotted, whatever you want to do. And when you graph this on WebAssign, you do need to be careful and graph them. Make sure those lines are either solid or dash according to the inequality symbol. So after we do this, we say x greater than negative 2. So the numbers that are greater than negative 2 are on the right side of negative 2. So I'm going to shade the right side, the whole right side. And you can see where it's getting like that darker green. That is where the two colors are overlapping. Let me color this better. So right there. Now, do we include that line? No, not at all. In fact, let me make it a little darker. Let's make a statement that that line is not part of it. And also, here, let's make this line very clear that it's a dash line. It's not part of our solution set. It's not a solid line. Okay. And okay, and we're almost done. We have one more. And this one here is interesting because it's going to be solid, but it's going to be horizontal. Solid because we have this equal part. So it's less than or equal, meaning the points on that line are part of the solution. Solid, horizontal line. There we go. And it's going across positive 3. So that will be 1, 2, 3. And this one is solid. Oops, I was not supposed to do that. And we have the symbol that says less than. So the numbers that are less than negative, the positive 3 are below. So below the line. So that will be here. And this color is not really helping, so it's not a good idea. I'm actually gonna, let's do this. Oh my gosh, I did it again. So all the stuff below. So now the region that contains the intersection of the, what colors did I use? So I used the light green, then we overlap the purple, so it turned into darker green. And now I want this area that contains the horizontal lines that I'm drawing or scribbling here, but also inside that darker area. And of course, below this blue line, that is not blue anymore, I just made it darker. Okay, and that was a solid line, so we were on the right track. So let's do this. Okay, yeah, I'm just making it more like way messier. So if you notice here, that area is what looks here brown, and you can see it here as well. So that will be the solution to the set. Now, if we were to test a point, such as, remember the easiest is 0, 0. If we substituted 0 here for the x, is 0 greater than -2? Yes. If we substitute 0 for the y, is 0 less than 3? Yes. And if we do it here, we already tested it, and yes, it was true. So that is the solution. Now, to find the vertex, or in plural, the vertices of the region, you solve the 3 systems of corresponding equations obtained by taking pairs. So, for example, the first one is taking inequalities 1 and 2. This is with inequalities 1 and 2. 1 and 2. And then here for vertex B is equations 1 and 3, or inequalities, but here we're turning them into equations, as you can see. And the third one will be inequalities 2 and 3, but here are equations. So if we solve that, those will be the vertices. So the solution of this one will be the only point where the -2 is x and y is 3. So that will be one of the vertices. And then the other ones, if y is equal to 3 and you substitute a 3 here, you will obtain that x is equal to 2 plus 3, which is equal to 5. And that's what we got here for x. And we already knew that y was equal to 3 because we had that inequality. And finally here, if x is equal to 2, and we take the system and we turn that into a 2. 2 minus y is equal to 2. So then we could say 2 minus 2 is equal to y. So 0 is equal to y. I'm doing something wrong. Oh, this is -2. -2 minus 2. So this will be a -4 equals y. And that's how we obtain that intersection point. So that one, -2 comma -4, it will be right here. This one. And then we have the 5 comma 3. So that will be right here, 5 comma 3, and then the other is the -2 comma 3. So -2 comma 3. This one was 5 comma 3. And then here, I forgot what it was. -2 comma -4. Okay, so let's just go ahead and let me show you how you will graph this type of inequalities on Desmos. So we're going to be graphing the exact same system. So let's keep this available here. So first we're going to graph x minus y is less than 2. So I have Desmos here available. So I think the easiest thing to type things on Desmos is by using their own keypad. So we had x minus y, and then I'm just going to double check. So it's less than 2. Less than 2. And you could see how Desmos is showing us the dash line, and it's also showing us the correct area to color. So isn't it that wonderful? Now I'm going to graph the next inequality, and that is, let's see, x is greater than -2. So x is greater than -2. And you could see now it's graphing it in blue. Since it is greater, it's shading the right side of the vertical line. The vertical line is dashed as well. And you could see the intersection of the red and blue already happening. It's creating this kind of like almost purple. And then let's graph the third one. And the third one is y less than or equal. This one has the equal part, so it's very important. So y less than or equal to 3. Y is less than or equal to 3. And that is green. And now you can see the intersection of those three colors, the light red, the light blue, and the light green is giving us this like dark green area. So for this area here, you could see it, or I don't know, maybe like a light brown. That is where all three solutions to each inequality intersect. Therefore, that is the solution to the system. Will the dashed lines be part of the solution? No, that's why they must be dashed or dotted. Will the solid line be part of the solution? Yes, absolutely. Will the points of intersection be solutions? No, because you're intersecting a dash and a solid line, so no. If there were two solid lines, yes, the intersection points will be solutions. But in this case, only everything that is inside, not touching the dash lines, but the solid line, yes. So that is another great way to find your solution. You could also check your intersection points or vertices here with Desmos. There you have it. Okay, so let's get back to this. And with more complicated regions, two border lines can sometimes intersect at a point that is not a vertex of the region, as you could see below. So if, for example, the system here, I'm going to count, we have 1, 2, 3, and 4. We have 4 inequalities. So the intersection of all of those 4 is this irregular, what is it, quadrilateral. It has 4 sides, but it's irregular because not all the sides are the same, you know, whatever. So that is the area. However, this intersection of two lines is not inside the region of the solution of that system. So even though it is an intersection, it's not considered a vertex. So yeah, this will be like a challenging one. Now, I believe on WebAssign, when you graph the solution to your system of inequalities, you don't need to graph all of the inequalities one at a time. You just graph the very last one. You graph all the lines, whether they're dashed or solid, but the only region that you will color will be the one that is like where all the colors intersect. So feel free to use Desmos to first, you know, get your solution system. You could check it by hand or do it by hand, check it with Desmos, whatever you prefer. And then in this case, if I'm answering this question on WebAssign, I will only shade the area where all the colors intersect. And if you have trouble graphing, please try the online tutoring. We have great tutors, and sometimes they don't have students during the week. Okay, now one very common application is the equilibrium point for a system of demand and supply equations. And the next example discusses two related concepts that economists call consumer surplus and producer surplus. So if your producer has a surplus, is because they have more items than the ones that they are selling. So they have, let's put it here, extra items. Whoever's making the items. And a consumer surplus, I am not sure, but that will be, I'm going to interpret it as like a higher demand. But we'll see. So the consumer surplus, okay, let's just read that. The consumer surplus is defined as the area of the region formed by the demand curve, the horizontal line passing through the equilibrium point. Remember equilibrium point from revenue and cost? It was the intersection because it's where the cost is equal than the revenue. So here, the equilibrium point of demand and supply is where the two lines intersect. So, for example, here we have demand is a line. I know they're calling it a curve, but we just use that word in general. So the demand curve you see here is going to be this line. And then we have the supply curve. So that will be, where is it? Right here. So it will be this line. Okay. Then the equilibrium point, as we already mentioned, that is this point where the supply and demand curves intersect. And if we trace a horizontal line passing through the equilibrium point, is this here, and we call that the p-axis for price. So then the area that is above that line is considered to be the consumer surplus. So I'm just going to change the highlighting here so it matches our graph. So that would be the consumer surplus, and then the producer surplus will be here. Okay. So that is similarly, the producer surplus is defined as the area of the region formed by the supply curve, the horizontal line passing through the equilibrium point, and the p-axis. In fact, I told you something wrong. The p-axis will not be the horizontal line, but it will be this one here, right here. Instead of y, we're using our dependent is price. And then here, x is representing the number of units. So the price depends on the number of units. The consumer surplus is a measure of the amount that consumers will have been willing to pay above what they actually paid, whereas the producer surplus is a measure of the amount that producers will have been willing to receive below what they call received. Okay, so this is a little different than what I teach in the business math. So I need to kind of like just transfer my knowledge to this definition. Okay, so what we do a lot in business math is we talk about the surplus, like excess of items, like I said before. But here, what I'm understanding is that, let's read it again. Producer surplus is the measure of the amount that producers will have been willing to receive below. So if we look at the graph, based on the price, the producer surplus is going to be a measure of the amount that producers, so I guess amount of money, because the dependent variable, the output is the price, will have been willing to receive below what they actually receive. So I guess that's why it's below the equilibrium, the horizontal line traced around the equilibrium point. And then the consumer surplus, which is above that line, is a measure of the amount that consumers will have been willing to pay above what they actually paid. So yeah, I think it does kind of translate to what I was thinking. It's for example, if every time a new phone comes out, and they run out of them, like people are willing to pay more than they should. So yeah, it's like the opposite of having extra products from the manufacturer. So if you make a certain item and you sell it for a very high price, that item might not be sold and you might have an excess of that item. We call that surplus. Or you might be selling it at a really good price, so then you're going to run out of items to sell. And that is and I know there's a word specifically like assigned to that. So okay, I had to Google that. A shortage. So you will be short of those items. If you're selling them at a really good price, the demand will increase. So then the producer will run out of the items, or the store, and so that will be considered a shortage. So that's what I was thinking. But let's stick to what this book is defining. So we have example 8, and it is the consumer surplus and producer surplus. So we have our two equations here, and it says the demand and supply equations for a new type of video game console are P equals 180 minus 0.00001x, and that is the demand equation. You could see how the slope right here is negative, so it's going to be leaning to the left. And then the other one, the slope is positive, so it's going to be leaning to the right. And here, the X is representing the number of units, and then the P is representing the price. So the place where those two are going to have an equilibrium point will be where they intersect. So we have this again. P is the price per unit, and X is the units, number of units, and we got to find the consumer surplus and producer surplus for these two equations. So let's see. So one way to solve them, since they're both equal to P, and we know that this P is equal to this P, then we take each expression and we just simply equal them to each other. That's what we're seeing on the next slide. So from here, we solve for X, which will be, we could do the following. We could keep the 180 here, the numbers, the constants, take this 90 to the right side, so it will be negative. We keep here our X term, 4 zeros. And then we take this negative quantity to the right, so it will be positive. Okay, and oh, I'm missing the X. X and X. Actually, I'm gonna just rewrite it. So if we add the right side, combine like terms, so we will have 0.00003x is equal to 180 minus 90, which is 90. And then, of course, we divide. So x is equal to 90 divided by 0.00003, and we obtain 3 million units. Which corresponds to an equilibrium price of 150. How do we know that? Well, if we take one of our original equations, let's say that one, and remember it was P equals 90 plus 0.00002, and instead of x, we use the number that we found for x, the one that we came from here. So we substitute there the 3 million. And what we get after we simplify that, it will be $150. So at a price of $150, that's where we will have the equilibrium point to our supply and demand equations. Okay, so to find the solution, we have here the inequalities. And I want you to notice that the consumer surplus was defined as what they're willing to pay above the price. Remember that. And so because of that, we will use the greater than here. Now, for the producer surplus, and the 150 is the equilibrium point. Remember, we were trying to find this point here, and that's what we found on the previous slide, and it was for 3 million units, actually. The price was 150. So that 150 for the price, that is where we traced that line. And so for the consumer surplus, it will be above that line. And then for the producer surplus, it will be below that line. Now for the I forgot the name, so I need to go back up. Sorry. Demand. Okay. For the demand equation, that's the one with the 180. Here. This one here. Well, that's the inequality. So I'm going to write the demand equation here. That was the P equals 180 minus 0.00001x. So that one is graphed here. Remember, I told you it was going to be leaning to the left. And so the consumer surplus is the area that is in between. Now, this equation here, all it's doing is just making sure that we don't go past that. So that's where we're saying x greater than 0. So we're taking everything on the right side of 0. Of that vertical line. So that's why we have that third one there. And the reason we use the less than here is because we want to get the area between that line and the equilibrium point line. So we want whatever is below this line. Now, lastly, with the, we say that was demand, right? So this is the supply equation, and that will be the P equals to 90 plus 0.00002x, and that will be this line here. And we have the greater than or equal because we want that area that is between the equilibrium point, the horizontal line, and the supply curve. So there we have it. And if you are not sure on how to solve something like this, we could go Oh, wow, we still have to do something, but let me show you how you will graph this one. So I'm gonna delete what I have here. And okay, so we start with, let's just graph the demand equation like you see it here with the equal sign. So 180 minus 0.0000, and I believe that's 1 in the next. Okay. We cannot see it because we have to change the viewing window. Now let's graph the other inequality, which is producer surplus. So P equals 90 plus blah, blah, blah. So, and I'm actually going to put a Y equals here. Here too. Y equals, and this is 90 plus 0.0002 X. Okay. Then we had that the horizontal line at the price, Y equals 150. There we go. And then we had the X equals 0. Okay, so I have everything graphed here like in like equations, not like inequalities. So let's see if we can see any of those. Okay, so we're starting to notice some of the lines. I'll change the viewing window in a minute. So since we got this equilibrium point was at 3,150,000. So let's change our viewing window. So I'm going to press this and we're going to change this from, let's say from 0, oops, from 0 to, let's say 3,100,000. Okay, and our Y, let's change that from 0 to, we want to go above 150. So let's say 300. Okay, so let's see. Now we can see here's the equilibrium point, 3,150,000. Here this red line is that horizontal line traced by the equilibrium point. Now what I'm going to do is the coloring. So let's see. We want to be on the right side of 0. So here I'm going to change the equal with greater than or equal to 0. Oh, okay, great. So color everything. Let's change this to something lighter. Okay, let's try that. Then for the line in purple, we are going to also change here. Now, do we want to shade above the purple line or below the purple line? Well, it's going to be below because we want the area here between that line and the red line. So we're going to use less than or equal. There we go. And then for this one here, for the, I need to see what it is. For the supply equation, the one down here in black, we are going to switch that. We want to color above that line because we want to get the area between red and black. So it's going to be greater than Oh, what did I do? No. Greater than or equal. I'm going to change the color to something lighter. Let's see. Let's try green. Okay. Oh, something happened here. I deleted the X. There we go. Okay, so now we can see that better, and to find the vertices, remember you can solve the system, or you could use decimals to find those vertices, and so your solutions will be located there. Now, since we're talking about the area of a triangle here and also here, so to find the area of a triangle, we're going to use the formula base times height divided by 2, and that is what you could all see on the next slide. So to find the consumer surplus, we will have the and let's do that by just getting rid of this one here. There we have it. And let's change this to greater than. So that area will be this triangle in here with those vertices. So you could see the base will be 3 million, the x-axis. The height will be 180. So let's write, you could see that here, 3 million for the base. The height, oh no, okay, let me make sure. What am I doing? Oh, I'm sorry. So yes, I'm sorry. If the price is 150, correct? And we just want this length here is not 180. That was very wrong from my part. It should be 180 minus 150 so that we could get the space in between, which is equal to 180 minus 150, and so that is 30, okay? So this height will be 180 minus 150, okay? Don't forget that. And then if we multiply that and divide by 2 or multiply by 1/2, we will get $45 million of consumer surplus. And for the producer surplus, let me show you with the graph. So now we want this one, we don't want this one, and we want this to be greater than. Or equal, I should say. No, less than or equal. That's what we want. Okay, so what we want is this triangle here. So I'm going to point to the vertices. There we go. So this triangle here, and you could see how the base will also be 3 million for this triangle. Then the height of the triangle will be from here to here. So it's going to be the difference between 150 and 90. So we can get the length here. So the height for this one will be 150 minus 90. And that's how we get the 60. The base is also 3 million for both triangles. And then after multiplying that, dividing by 2, we get 90 million. So at that point of equilibrium, the point of equilibrium was 3 million and then 150. So it was like 3 million units, 150 was the price. So at that point, the consumer surplus will be 45 million and the producer surplus will be 90 million. And that is the end of this section. I don't think I assigned difficult problems on the homework, so please just do it as soon as possible so you don't get behind. Thank you for watching.